Okay, so for the benefit of the recording, this is the code along in week 8, and I'm going to start by talking a little bit about something that's not related to what we're going to do in the rest of the code along, but I think could be useful because I don't think we've talked about this very much. I don't think it comes up a great deal in the videos, and if anyone is still struggling with some of the homework, this might be useful for you. And if not, it's probably still just a useful thing to talk about. So I don't think we've talked a lot about functions and how functions work in R. And I just wanted to give some examples of using functions and sort of how you define them and how you might go about working out how the code is right. So I want to start with a fairly simple example of a function. It's about as simple as I can make it without it just being a function that already exists. And so it would be pointless for me to make it. And suppose that I wanted a function that is this. Let me share my screen. There we go. So suppose that I wanted a function that, just get rid of that window. Suppose that I wanted a function that evaluates this polynomial. So this is a quadratic. So we want to take x, square it, add on 3 times x and add on 2. So obviously it's not a thing that's a built-in function in R. There's no reason why that would be there. But suppose it was just for some reason it was useful that I could evaluate this polynomial. A reminder, by the way, that I cannot see you when I'm sharing. I can see the chat, but I can't see you. Yes, I do look like a ghost. My backlight has broken. I have a light that sort of bounces light off the white wall and gives me a bit more color. But unfortunately, the bulb just went as I tried to turn it on this morning. So you're going to have me in sort of slightly gray this morning. This is the function that we're going to have here. And the thing is, if you wanted to, the thing that you sort of have to be aware of with R is the syntax for functions. So when you define a function, it's not like any R code that you've necessarily seen before. And it's always this format. So it's name of function, no brackets, just the name of the function, an assignment to say we want to create a function that has that name. And then this special like function making function called function, very helpful. So we write function brackets x, and the thing that's in the brackets here is the name of the variable for our function. So this can be absolutely anything that's sort of legitimate name for a variable, which is basically the same set of rules as for like a legitimate name of an object. So you can put underscores in, you can put full stops in, and you can use capital and lowercase letters, and you can use numbers, but in certain contexts, you have to be careful with numbers. So here we're going to call it x. So our variable is x, and we then have some curly brackets. And so what this is going to do, what this function does, is it takes x, it does to x whatever is in the curly brackets, and it returns whatever is on the last line in the curly brackets. So that there's only one line in the curly brackets here, and it's this. So what it's going to do is evaluate that and return that as the output. Now, the problem is that what we can't do with this is try running each line of the function on its own, sort of naively without doing anything first, because x doesn't exist, right? So if I try and run line 6, I'll get an error, object x not found. And that doesn't actually mean there's anything wrong with my function. The function is perfectly fine. That is a correct function. The problem is that x doesn't exist. So there are a couple of ways to get around this. There are debug tools in R itself. And because I've not got a huge amount of experience with them, I'm not going to talk about them today because I might mess it up. But I'm going to talk about the sort of rather hacky way of testing a function, which is what I often use, which is this. So let's start by just now, temporarily, x doesn't exist, right? But we want to check that this function is doing what we want it to do to x. So let's just have a line of code here. Let's do it here. In fact, that is x equals 4. And now you can see x has popped up in my environment, which means I can run this line of code. And I get the answer 30, which if I wanted to go and get a calculator and check, that should be right. Let's see. I'll do it in my head. 4 squared is 16. 3x 3 times 4 is 12. So add those together. That's, can't do that. So 28 and add the 2 is 30. There we go. So that's now working, right? We could try a different value. We could try -4. And we get 6. So that's going to be 16 minus 12, which is 4 plus 2 is 6. Yeah, that seems to be working. What we have to remember to do, because that's going to be confusing now, because we have x as both a variable and as a placeholder in the function. And R can deal with that. R's sort of behavior is that if there's a placeholder variable here, it will interpret anything in the function as referring to that variable and not to anything that exists outside of the environment. So this won't cause an error exactly. But so, you know, if I assign x equals 4, and then when I define my function, if I, whoops, come to that later, when I define my function, if I try running my polynomial 3, it's perfectly happy to just ignore the fact that x equals 4 and use the value of x that I just provided here. So yeah, what you could do is write my polynomial in line 8 and run the whole script. That would be totally fine as well. So that's the other way of debugging it, is just to assign the whole function. And that's probably what you'd actually do with this relatively simple example, is you just define the whole function. But what if you were built, so the reason I'm talking about other ways to do it is that it might be your function is quite complicated and you need to check as you're going along that you're doing the right thing each time. And that's what happens on exercise 1 of homework 3, right? Is that you have to write quite a complicated function and you want to kind of check as you're going along if you're doing it right. So I'm going to give you a slightly different function now. And that's horrible. It's not as horrible as the one that you have to do on exercise 1 of homework 4, but it's a little bit more unpleasant. And you can see now where that I might not want to run the whole function, write the whole function, test it, and then see what's going on, because it might be that gives the wrong answer, but it's somewhere buried in the script and I don't know where it is. Out of interest, in the chat, does anyone know what this function does? Anyone can guess what this function does? Yeah, it's the quadratic formula. Yeah. So what it's doing is, this is to deal with the fact that R handles complex numbers in a kind of weird way. It's testing whether the discriminant is at least 0. If it is, it's returning the two values that are real valued, and if not, there's a little hack you need to make square root actually return a complex number, which is to stick 0i in. Because if I didn't do that and just run this for the case of discriminant 0, I get an NaN, and what I actually wanted to do is to return a complex number in those cases. But I don't want it to return a complex number in the cases where it's a real value. If I just put plus 0i on all this, I would get like real value plus 0i, and I don't want that. So what I want is a complex number if I have to, but otherwise just treat it as a real number and evaluate these two things. So I've used an if else here. So if else, so our function here has 3 inputs, right? It has 3 inputs called A, B, and C. So again, if I run this line of the code here, it's going to give an error. Oh, well, firstly, it gives an error because it doesn't know where the function if else is. That's a different kind of error. So that is a mistake. That's that I need the tidyverse to get that function. But now let's try running this again. It's still giving an error. Object B not found. And yeah, because B is a placeholder. B doesn't exist. And that doesn't mean there's an error in the code. That just means that B doesn't exist. B is just a placeholder. So for this one, yeah, we could define the whole function and then stick some values in. But let's say I just want to check one thing. What I might do is put, let's say, let's pick something where I can easily work out what the roots are going to be. So if I say A is 1, B is 0, and C is minus, so it's been a while since I've done this, -1. So we'll define those, and then, oh, I didn't mean to define the whole, run the whole function yet. I just want to run that code. Oh, and you see I've got an error. So if I'd run the whole function, and if I try it now, my formula 101, give me an error. False must be a double vector, not a complex vector. So we've got a problem. The problem, I think, is that if else can't deal with complex numbers going in here. So let's try the naive one from R of if dot else. Is it just if else? I think it's just if else without let's try that one. See if that, oh, error. So, and you can see why in this case, I didn't mean to create these errors, by the way. This is genuinely, I made a mistake. But it's more helpful that I can step through the function and check that things are working rather than have to run the whole function in one go. And the only way I can do that, well, there's a few ways I can do that, but the only way I can do that without using a specific debugging tool is to define some values of A, B, and C first, and then work through the function. So if else, right. So the arguments of if else are called yes and no, not true and false. So let's try and see if this works now. Yeah, so that's working, and left is -1, which is what I expected it to be, and right is 1, which is what I expected it to be. So now what I probably want to do is clear my environment, because it's not helpful to have this A, B, and C floating around when we're really using those as placeholders. But we'll now remove them. We can rerun library tidyverse, redefine the function, and what we can then do is we can start using it. So my formula, let's see, 4, 5, 6 gives a complex answer. My formula 4, 5 minus 6, it's a real answer, and that's what we wanted. Good question. How can you clear just one thing from the environment instead of all of them? It's a really good question. I'm just going to look that up. Give me one sec. Sorry, I've just stopped sharing while I get a different window open. So I didn't know it was about to just pop up on my screen, so I needed to. I always forget the function for this. I believe it's remove. Yeah, it's remove. So it would be, so let's say we defined, let's put it in console for now, A = 1, and then I want rid of that, remove A, just get rid of it. So that would be the other way, is to just write, we'd have written remove ABC, and that would get rid of it. So that was a little bit on functions. Does anyone have any questions on functions? Because I want to make sure that we've sort of covered this reasonably well. I think one thing that we're thinking of doing for next year's version of the course is to spend quite a bit more time talking about how functions work and how you would use them. I'll just stop sharing for now. Also, because I need to get my prep file open for the rest of the codal. Someone else, can you have a loop in a function? Yeah, we haven't talked about loops formally in the course, but you absolutely can have a loop in a function. You can have any code in a function that you want. So I'll just tell you, just for the benefit of everyone else, because we haven't really spoken about loops, there are two basic kinds of loop, and a loop is where you tell R to run the same code over and over again. So what we try and do is do things via these map functions. So when we use the map DFR function is the one you need for the homework. When you use map DFR to map a function over, to run the function over the different URLs, to scrape the different URLs, that's a way of avoiding doing a loop. So the other way of doing that thing would be to write a loop that it will be probably slightly slower and it's a little bit less neat, but will be to write a loop that iterated over every element of that vector. And so it said for every element in the list of URLs, in the vector of URLs, scrape that URL. You could put that in a function as well. Can you call a function within its definition to create iteration? Yes, you can. You've always got to be, oh, sorry, I forgot to say the other kind of loop. So there are two kinds of loop. One is do something a specified number of times or for every element in a vector or something like that. It's called a for loop. You're doing it for every element in the vector. The other type of loop is called a while loop, and that's it checks whether or not some condition is true, like while I is greater than 0, and it keeps running something as long as that condition is false. Yeah. So actually, in the function that I wrote, the one that modifies a function in forcats I think that includes a while loop because it is it sort of goes down each element of the factor, and while the it keeps running, keeps adding things to the other category. So this function is to make an other category in a factor in a categorical variable that's smaller than the largest category. And what it does is it keeps lumping things into that category until that adding another thing would make it bigger than the first one. So that uses a while loop. Can you call a function within its definition? Yes, you can. So you could write a function that calls itself. You also have to be careful with that, because if every time you run the function it calls itself, that will create an infinite loop and the code will never stop running until R crashes because it's run out of memory. But you can do one that does like, if something is true, call this function. If not, if not, stop. And that's typically the way that a lot of, so a classic example would be a sorting algorithm. So if you have a vector that you want to write a function to sort it into a particular order, and R already has functions for this, so you don't need to write your own other than as an exercise in coding. But a typical way to implement that would be, maybe split the list into two, sort those lists, and then merge those together. That's a particular sorting algorithm. And you could implement that by firstly split the list into two, then call this function on each of those lists, then merge the lists together. And I think I might even mean merge sort. And the condition you'd have to stop is if the list is of length 1, just don't split it into 2 at all, just return itself. Any other questions? Yeah, a few people have mentioned that. I think there may be some extraneous, I think that's possibly partly to how the website's changed. So the question, for the benefit of the recording, is in the homework 3 function, there's a task to remove extraneous white space from the names variable, but there doesn't seem to be any. I would just run that function anyway. It won't do anything, and it will make sure that the markers don't get confused as to why you haven't done that. But yeah, I don't think there is any extraneous white space necessarily. It's just that their website has changed since last year. And there are a few things where we didn't properly change the homework. No, you don't need to copy the functions to the MD file or the RMD file, because that will, so if you copy them to the MD file, when you knit, it will just get overwritten, so there's no point doing that. If you copy them to the RMD file, it will mean that they run every time you knit the file, and that's very much what we want to avoid. So please don't copy the functions to the .md file. The markers will go into that. Normally, the markers only mark the .md file. In this specific instance, because we've told you to write a separate script, they will look at that script and they will look at the .md file other than that, but they won't look at the .rmd file. It's the first 10 rows is what it means. That it doesn't mean the top 10 by values. It literally means the top 10 in if you were to print out the whole table. So when it says print the top 10 rows, it just means print the beginning of it. which is what the default behavior of printing Tibbles is, that it prints the first 10 rows. Someone says, when I used the root link that was given, it scraped the same page over and over. Yeah, that was, again, that we forgot to update it properly. We did put a note of that on fairly quickly. We put a note on that on exercise 2 in the sidebar, that it was the wrong root link. But yeah, sorry, once we push the homework repo to everybody, it's very hard for us to change it without overwriting people's work that they might have done.
For context, the way you interact with Git is the different way to how I interact with Git, because you interact with Git with one project, I interact with Git with 350. And so the ability to commit to your project has a small chance of overwriting your work. So we just don't do it. Meaning that we're more likely to edit the instructions than we are to then go in and edit your templates after they're made, just to avoid a problem with overwriting, which you won't get because you're using it slightly differently. You got merge conflicts, you got all this other stuff. The way we do it, because we have admin privileges, is there's a chance that if I pushed a thing, it would overwrite. And I imagine that would be a much bigger problem than just whapping it in the instructions and saying, we made a mistake, here's a correction. So that's what we'll typically do. And luckily we haven't had to do that much on the course yet, but we realize homework free, because web scraping changes a lot. There was 1 or 2 things that we missed.
Instantly, we are looking at whether David's God essentially. Don't you may not want to stoke his ego quite as much as that, but yeah, I don't know if I said that clearly enough for the recording. The chat says David's God essentially. Someone else says King David. Very good, very good. Yeah. In theory, I think I have these privileges as well. I just don't know how to use them. Thank you for saying that I'm also God. I appreciate the equality that we're getting here. Yeah, so yes, the web scraping stuff is something that we're considering removing for next year. And if you have any thoughts on that, we'd be interested to hear them. Because it does cause us issues in updating things year on year as websites might change and so on. Okay, so I'm going to talk about the main bit of the code along. It's obviously going to be a relatively short session in terms of the code along this week, but I am that's fine. I was ready for this. So the data set that we're going to look at is about pubs. So I'm going to share my screen. So actually, this data set is not one that you can find in this form on the internet. Hopefully you can see this again. This data set you can't find on this form on the internet. I made it. I made it by going to these 5 data sets that I could find and cleaning them up and joining them together. And that was a bit of a pain at times. So if you're ever working with, I may as well tell you a little bit about this. If you're ever working with UK data, so I'll show you the data set actually, it's going to be the simplest way to start here. So let's run this code chunk and then read our data in. So if you're ever working with UK data, geographical data, statistics data, you'll see that each area has an area code. There is a format to this. The first few digits here correspond to the type of area it is. So there is a method to this. In this case, the E means it's an English area. The next 2 digits depend on which country it's in, which nation it's in. They mean different things in the 4 different nations, but in England, 06 means that this thing is what's called a unitary authority. So that means a council area where that's basically the only council. So some areas of the UK have counties and districts, and the districts are lower than the counties. But some areas of the country, like where I grew up, Bradford, Bradford's slightly different. I'll come back to that. Some areas of the country have just one council, and and those are called unitary authorities in England. And some areas, like where I grew up, Bradford, there we go. Let's find Bradford. Is Bradford going to come up anywhere? There it is, Bradford. So Bradford is an EO8, and that means it's what's called a metropolitan district, which these days is basically the same as a unitary authority, but there are some very minor differences in how those work. It's basically historical reasons that they're different. And then EO7 means that it's a district where there's a county council as well. So Harrogate district comes under North Yorkshire County Council, as does Craven, as does Hambleton, and so on. And then you've got all sorts of other kinds of districts. EO9, I think, is London boroughs. You've got W for Wales, you've got S for Scotland, you've got N for Northern Ireland. The Welsh and Northern Irish districts are much simpler. WO6 means a council area in Wales, but there are different codes for like larger areas in Wales as well, or maybe parliamentary constituencies, so the areas that elect MPs. S12 means a Scottish council area. NO9 means a Northern Irish council area. These things are typically simpler in Scotland, Wales, and Northern Ireland than they are in England, where there's just a general mess of different kinds of things. The thing that does complicate it is sometimes the Office for National Statistics decides to change these codes. And sometimes it changes the codes because of politicians' decisions, essentially. So because they've made the decision that certain of these districts need to be amalgamated into a new one or change in format and so on, and it just has to respond to that. Sometimes it changes the code for no reason that I can determine. I don't know why. I'm sure they have a reason, but I can't find an explanation. So for instance, if you look at my cleanup script, various of the things that I have to do, Janta's not installed, interesting. Various things I have to do, for instance, is Fife had its code changed in around 2018. I don't really know why, but the problem is, if you want to join data, joining by name isn't a sensible idea because these names can vary across different data sets for the reason that you can have things like, so let's go to the Scottish ones at the bottom. It's loading now. That's not helpful. There we go. It's because it's trying to install back at the same time. So if we go to the Scottish ones, we can't join by area name because sometimes this is Glasgow City and sometimes it might be City of Glasgow. And sometimes this is City of Edinburgh, and sometimes it's Edinburgh, comma, City of, and all sorts of annoying little things like that, where the name is just encoded in different ways. Sometimes and will be an ampersand. Sometimes people forget to put commas in. There are all sorts of things that can go wrong. So it's much more sensible to join by this unique identifier, which is the area code. Unfortunately, sometimes they change those, and then you have to account for that. So this was a messy process. I realized I was sort of ranting about about the way local government works in this country, and the basic point here is that it causes this cleanup script to be very long. A couple of things to say about it though, just before I go on, are that I did all of this. Every time I import a data set, I used the GUI method that I talked about in the video. So I went to the import dataset button. I went to from text reader or from Excel. That's especially useful for from Excel because it lets you make sure that you skip header rows, which can sometimes be encoded weirdly. And it lets me, so this would have been a pain to type out, right? If I'd had to type out text, numeric, skip, numeric, note, and so on. Like, I didn't want to do that. But I could just click on drop-down boxes and make sure that everything was as I wanted, and then just copy out the code and change the formatting a bit. So change it to here and the data instead of the file path it gave me and so on. So annoyingly, by the way, sheet equals all doesn't mean read every sheet of the Excel file. It means read the sheet that's called all. So that's not helpful either. Anyway, there we go. So I did all of this cleanup and I made the data set. And the other thing I wanted to talk about here was, let's say, preview and viewer pane again and have a look at this. And the other thing I want to talk about then is the data dictionary. So because I made this data set, I needed to make a data dictionary for it. Because well, I didn't make it, I didn't collect the data, but I did join everything together, and it was going to be annoying for somebody to have to go back, even though I'd sourced them. So if you look here, I have sourced every one of the data sets that I obtained. But I also needed to explain where the data came from. So I'm going to do that now. Talking out loud. So the area code, as I said, is the ONS area code for each district. The area name is the name. And this was the thing I was interested in, the number of pubs in each district. So pubs being the UK's sort of, we might call a bar in America. I was interested in whether or not there were any patterns, any other variables that could explain this. And I picked a few things that seem like interesting demographic things to try. The number of pubs in each district, the population of each district was the next thing I got. And that let me get the number of pubs per capita, because that's now a continuous variable. And it also controls for the fact that a very obvious thing would be that the number of pubs in a district will probably be positively correlated with how many people are there. It's not 100% true, but it's mostly true, because more people means more custom, means more opportunities for business to open, more towns, meaning, and so on. So I got these two values, and I got the pubs per capita by dividing one by the other. This is now a continuous variable that I can try and do some regression on. The country is which UK nation each district belongs to. So there are 4 nations in the UK: England, Northern Ireland, Scotland, and Wales. And there's a variable that encodes that. So that's obtained by, I think it was in one of the data sets, but I removed it at some point. And so I could easily get it back by using that first letter in the ONS area code. The median pay, which I got from the 2017 data, for the reason that that was the one that matched up with the districts as I had them in my data set, at least reasonably closely. I think that one was missing. Yes, some of them are missing, and we'll talk about which ones are missing in a minute. But some of them aren't there for certain districts. Oh no, I remember. The median pay, the figures they had for Northern Ireland were just overall for Northern Ireland. There wasn't a separate one for each council area in Northern Ireland. We don't have data for that. There's the area in square kilometers of each district. There are various different ways to measure area. This is all, so all of these things are things people have to think about. I guess that's the message from this bit is, when I did this, I had to think, well, actually, which one of these things was I interested in? Was I interested in the area? If I wanted the population density, I probably want the one to what's called mean high water level, because it's not really relevant how much beach somewhere has. People don't live on beaches. People live near beaches, but not on them, and certainly not below mean high water level. So people don't live in the bit of the beach where there's tide, essentially. So that's what I was interested in. And the population density is how many people live there. So I was wondering if maybe there would be fewer pubs in areas with higher population density. Actually, that was my hypothesis. Because I'll talk a bit more about, actually, I'll come back to that. So the population density, again, wasn't a thing I got directly. I divided one thing by another. And then finally, we've got life expectancy. So the life expectancy at birth of people born in each district. They give the data for female and male. As far as I know, everybody's birth certificate in the UK has to have either female or male on it. There's no intersex option on birth certificates. So that's why it only has those two sex variables in here. That one I had to obtain, actually that was in long format, and I had to make it wider for once. So this had a row for male and a row for female for each thing. And what I had to do was pivot it wider so that I had columns for female and male, because I just wanted those as two separate variables, very heavily correlated variables, as you might imagine, but two separate variables for each area. So let's talk about hypotheses. So the hypotheses that I might have here are that, so I said that the number of pubs I expect to be positively correlated with the population, so fine. The pubs per capita then is what I'm interested in taking to my predictor variable. as my response variable, and I'm interested in most of the others as predictors. I suppose the sort of groups variable that I might take would be to see if things differ in each country, so in each nation. So those are the sort of groups that I'm going to control by. We're going to be a little bit careful with that because there are far more districts in England than there are in Scotland, Wales, and Northern Ireland put together, in fact. So then the others, I would expect, I don't know what will happen with median pay, because there are a variety of things that can control that, to do with where pubs tend to open, and confounding things to do with which socioeconomic groups spend money on alcohol, which socioeconomic groups go to pubs as opposed to restaurants, but also if people have more money, they might be more likely to spend money anywhere, which might include pubs. So there's lots of different things that could happen with that one. I don't really have a hypothesis for that. I predicted that the number of pubs per capita would be negatively correlated with population density, for the reason that if people live close together, so a lot of villages have a pub in the UK. It's sort of, a village will typically have, if nothing else, a like general store / post office, a church, and a pub. And I was and a lot of pubs in urban areas have closed, a lot of pubs in rural areas maybe have stayed open, because they're sort of slightly more community hubs than they are in cities and towns. So I wondered if maybe there would be a negative correlation there, that actually the number of pubs per person, so the number of pubs sure might, it shouldn't change too much, but what am I trying to say? The number of pubs per person I thought might be higher in rural areas, so higher in areas with lower population density. And pubs are associated with consumption of alcohol. Alcohol isn't particularly good for you. So if anything, I wondered if there would be a negative correlation between life expectancy and number of pubs per capita. But again, I don't know if those are going to be particularly closely related. So those were my hypotheses. Okay, does anyone have any questions on the stuff we've done so far? Pop them in the chat if you do. I'll just pause for a couple of minutes. Well, 30 seconds or so. While people are maybe thinking of questions, I'll just say this is the sort of data dictionary we're looking for in your projects. It's useful to provide information like, if your data is from a particular year, which year is it from? If any of your variables, so a couple of my variables I've just made by dividing one column by another. Good question. Well, I'm just defining the script carry over to the RMD. Yes and no. So if I run the whole script, and I could run the whole script now, but if I won't do, because it'll take time. If I run the whole script, then those objects will be available when I run the code chunks in the RMD. The problem is that an RMD has to be completely self-contained, and it doesn't know that that script exists. So unless I explicitly tell the RMD now run everything in this script, it doesn't have any idea that that script exists. So it might work when I run, but when I knit, it's going to cause a problem. And I think this might have caused some errors for people on their homework. So what I have to do, the last thing in my cleanup script, I'll just open it again. My cleanup script actually creates 2 RDS files, because it creates a specific one of the pubs per capita. The reason it does that is that actually the pubs per capita has values for lots of different years, going back to about 2001, I think. And then the rest of the data, I could have gone and found lots of other data for every year and tried to do a time series type thing. I didn't for a couple of reasons. One, time series are complicated and we haven't really talked about them. 2 is that, which shouldn't stop you if you're interested in using a time variable in your project, by all means have a go at it. But the main reason I didn't is that some of these other variables were in separate CSV files for each year. And I didn't want to try and download every CSV file for every year just to get one more variable. So I just decided that I would stick to looking at 2018, which was the most recent year in the pubs dataset. So I thought I'd save that anyway, just in case if anyone wants to look at this and do it as a kind of coding along. If anyone's interested in looking at those data or joining it with something else, I thought I'd provide that for you. But the main data set we're going to use, if you look, I saved it as pubs-final.rds. And then one of the early things in the RMD is to then read that file back in. Someone asked, by the way, and I'll answer this question now. I'll answer it to the person who asked it, but I'll answer it for everyone else because it was a really good question. Someone asked, in your project, do you need to put your cleanup scripts in the proposal file, or in, is it acceptable to put them in a separate .r file? Do you need to put them in your final presentation or anything like that? Probably not in your final presentation. They're not interesting. Cleanup is something that's useful to know how to do, but if you were giving a presentation on your data analysis to somebody who was not a data scientist or training to be a data scientist, they wouldn't be interested in, and then I had to, and I realized this is very hypocritical of me because I'm now telling you not to say exactly what I just said, but telling them, and then I had to go and change the code for Glasgow City, and then I had to, these variables had different names, so I have to imagine they're not going to be interested. They just want to know what your data show. So I would say it's fine to have that as a separate cleanup file, as long as that file saves it and then loads it back in again. We probably want to see it for when we're marking your work, but you don't need to put it in. You don't need to put large amounts of cleanup script in any sort of .rmd file. That's just not necessary. I don't know if David has any thoughts that disagree with me on that, but.
No, I don't think so. There's different folders that you'll notice. Extra is a good folder to make use of things like scripts and stuff that me and Alex can kind of flick through, but are not going to make part of your core project, if that makes sense. So it might be an idea that when you're thinking about, well, how do I make sure that the folder for my project is self-contained, is neat, is easy to find my way through, when me and Alex are trying to look through for various things, think about how you want to demonstrate that to us. But by keeping the file structure relatively similar to other projects, it's also going to help me and Alex when we're marking find what we're looking for.
Yep.
But it might be that you want to put that stuff in the extra because it's not something that we necessarily we want to see in the presentation, because as Alex said, cleaning tends to take ages. It is not particularly interesting to discuss, but is important when me and Alex are trying to look for what did you do. So just whap it in there. Cool.
Any other questions on sort of data dictionaries or anything like that? We're not actually doing much coding along this week, I would appreciate. And I suspect what I might do is actually come back to this one in a week's time and actually work with this, because I did spend quite a while making this data set, and it would be nice to actually use it for something more than just 10 minutes. Okay, so I'm going to do some really, I'm never sure when the session's supposed to finish. I think it's supposed to finish at 10 to possibly, but I'll just talk for another 10 minutes. Feel free to leave if you need to get somewhere else. But what I'm going to do is, good thing that I said I might do this next week. Apparently some of the sort of prep I did, I forgot to save. Isn't that fun? So actually some of the prep I did, I need to redo anyway. But I was going to talk about models, fitting models to this. I'm probably not going to have time to talk about models today. But what I am going to do is talk a little bit about this data set, and then next week I'll come back and I'll see if we can do some model fitting to it. So let's firstly do the standard thing of, so we want an EDA section. And let's do the standard thing of taking a glimpse of this data set. I really like the function glimpse because it's been really useful when doing sort of assessing your projects. It really lets you see what all the variables are really neatly and whether or not there's going to be something useful we can do with them. So in particular, I know that area code and area name are not really variables that I can work with, as they're unique identifiers for each thing. And it's useful to have them around, but they're not going to be variables I can do any prediction on because they're just character values that are different for each entry. We've got the numbers of pubs, we've got the population, we've got the pubs per capita. We've got the countries, which are all coming as England here, but that's just because the English ones were first in the data set. We've got the median pay, the area, population density, and we've still got v4_2 hanging around, which I think means something's gone wrong with my cleanup script, because I should have removed that. Yeah, there's a mistake in my cleanup script. This should be, oh no, there isn't. No, maybe there is. Run that again. Nope. There's a mistake in my cleanup script, so that's another reason we need to come back next week, is that v4.4_2 should be the life expectancy, and it's not working. Let's just have a look at that then. Yeah. Great, that table doesn't have anything. Okay, what happens here? So this is debugging. So let's have a look at this. So lifex cleaned, if I break the pipeline there's nothing. So the problem is before that. It's worked before. I see the problem. Right. Right. I see what I did. So I made a mistake when I was, and I'll fix this for next week as well. But I made a mistake when I was actually sourcing the data and forgot which year I was working with and did 2008 instead of 2018. And I think I've improperly tried to fix that. So let's see if this looks like it should. Yeah, it's better. So actually these values at present are from 2006 to 2008. I'm going to go back and get the right values for that because it should be 2016 to 2018 to be relevant. But anyway, those are the data we've got. Okay, so we can do this glimpse of it. We can see the data. What I'm going to do is, what I'm interested in is, firstly, where are the NAs going to be? So where have we got missing data? Let's have a look at this. So this is probably going to be the last thing I do today. Okay, so what is the thing that I want to do? So what I want to know is, firstly, each entry, is it an NA or is it not? So there's a few ways I could do this. This is a slightly hacky way of doing it, where what I've done is I've said, okay, group by something that's different in every row, and then tell me if the sum of the is.na things in that row, which is just going to be either 1 or 0, is 1 or 0. Yeah. So what I'm doing here is for each group, which is a single row, tell me whether or not in that column we have an NA. So this is a slightly syntax you might not have seen before. So this is a cross function. You can use that if you want to do a summary across lots of different columns. So what I'm saying is, across everything, apply this function, sum is.na, for each group, which is each row essentially. And for the names, stick NAs on the beginning of it. So if we run this, what we get is NA's area code, NA's number of pubs, and so on. Okay, so what would I do now? what kind of statement would I use to say, let's get rid of the things where we get a 0 in each row? What would I do for that? What does colon colon mean? Someone asks. Where have I put a colon? I don't think I've put a colon colon, but I can tell you what it means. So colon colon means, so I'll give you an example. I'll come back to this actually. I'm going to do this next week because I think it is going to get a bit rushed for what we have to do. And I'll just take the general question. So what I'm going to do at the start of next week, I'll just give you an overview and I'll come back to the general question. What I'm going to do at the start of next week is firstly, look at where these NAs are occurring. Secondly, I'm going to, I need to fix my script a little bit. Secondly, I'm going to look at what the variables are and what patterns we might be able to see with some with a pairs plot. So I'm going to use the ggpairs function from the ggalley package that someone mentioned before. And then I'm going to try and fit a model. I'm going to pick a couple of things and try and fit a model to them. And I don't want to rush that, so I'll do that next week. But I'll take the question now of what does a colon colon mean? So when you want to use a function from a pack, let's assume you've installed any packages you want, but you want to use a function from a package. So there are two different ways to do that. One is to put library in the name of the package. So suppose I wanted something from janitor. I could do library janitor and I want clean names. So I could do clean names pubs data. This won't actually do anything because they're already cleaned, but whatever. So I could do that. But suppose I didn't want to load the entire janitor package. So if I run library janitor, it will, it's already loaded. If I, let me just restart R. There we go. And I'll run my packages again. So it's restarting just to so we unload all the packages. Give it a minute. There we go. So if we run our packages here, library tidyverse, library tidy models, library here. And then suppose I ran library janitor, and it's going to tell me the following objects are masked from package stats: chi_score.test, fisher.test. So what that means is that janitor has functions with those names as well. Suppose I didn't want that. Suppose I actually didn't want, suppose I wanted to use the original chi_score.test or fisher.test, and I didn't want to use the ones that janitor gave me. So I've now made it a little bit harder to access those functions because I've loaded two packages with functions with the same name, stats, which is essentially in base R, and janitor. And it will just take the functions that I loaded most recently. So it will take the janitor versions. So that might be a reason why I don't want to actually load janitor. I might just want to access certain functions from janitor without loading the whole package. So there might be other reasons you do this. It might be that loading a package takes a long time, which you might only need one function from it, something like that. So what you can do instead is, as long as the package is installed, it doesn't work if the package isn't installed, but you can type the name of the package, colon, and the name of the function. And what that does is it accesses the clean names function from janitor, but it doesn't load the whole package. So that's what it means. It means access this function from this package. So package : function is the syntax, and it means use the clean names function from the janitor package, or use whatever function from whatever package. So generally, if you only want one function from a package, you would tend to use this. A little cute thing is there's a package called emo, which I've got installed. And it's got nothing to do with the subculture. It's for inserting emoji into our things. So I've used it in when the little light bulb symbols appear in the Code1 write-ups. That is from the package emo. And that package is clearly designed so that you don't run library emo. And the reason it's clearly designed for that is that the function that you use to create an emoji is just JI, which means what you're supposed to type is emo : JI, and then the name of the thing. And of course, that then spells out emoji. So that package clearly was not designed that you run library emo and then run G and things. Okay, I think it's probably time to stop the recording. If David can do that.